Ladies and gentlemen, we've got a special treat here today on the Kurz Wind podcast for you. It's not just an interview with one particular individual. We have 4 guests on the podcast today from Nidec Industrial Solutions. You probably know these guys as the go-to encoder provider for the GE turbines. And now we're going to talk about how they're expanding into different applications within that tower. First, I want to introduce Brian Winter, who is the Director of Sales for Nidec Industrial Solutions. We also have Jose Carmona, who is the Regional Sales Manager of Wisconsin, Illinois, and Ohio. Benjamin McHugh is a sales manager out there in Ohio. And then off camera right now, and we'll get to him later on, is Steve Jensen, who is the Director of Product Management and Marketing for Nidec. Gentlemen, welcome to the show.
Thanks. We appreciate it.
Thanks.
So before we go into the technicalities of your product and some of the value adds that you bring to the wind industry, I really want to touch on your unique individual background. So starting with you, Brian, would you mind just kicking it off with a 30-second intro into your background and education and so forth?
Sure. Appreciate the opportunity, Dan. So basically, I'm an electrical engineer by degree. I've worked in the industry probably over 30 years now, and mostly in industrial automation of various types. I came to what was then Avtron about 15 years ago and started as a sales engineer like you guys are. I've also worked in the product marketing area like Steve has. And now I presently am the director for the sales force. We're really excited to be here, and we're really proud to be partnered with Kurz. You guys have been an extremely strong partner of ours for well over 20 years, and we're really proud of that.
I appreciate that, Brian. Big time. Why don't we move on to Jose next? Jose, quick intro to your background.
Yes, by degree, I'm mechanical engineering. I started off in some design work, but quickly realized that I had a calling for sales. So I joined Avtron, Nidec Industrial Solutions, over a year ago, and been hitting the ground running ever since.
Wonderful. And then Ben?
So I just graduated from Montana State University, where I studied mechanical engineering and had a minor in aerospace. I graduated just this past May of 2020. And so here I am starting off my career with a sales engineering position.
That's great. Congrats, Ben. Montana State, too. So were you born and raised in Ohio, or did you make your way out for this job opportunity with Nidec Industrial?
Yeah, it was a great opportunity, so I was able to come out here. I actually grew up in Denver, Colorado.
Very cool. And we will get to absolutely, and we will get to Steve later on in the podcast. I really want to start this podcast by talking about your product. As we know, there's a lot of different encoder applications out there. It's wind, there's industrial applications. We're going to focus heavily on wind for this particular show. Ben, we've seen the new Avtron blade pitch encoders in the field. Could you just briefly touch on why they're different and really why they're the superior product in the field?
Happily. So we call these blade pitch encoders the AV56 Gen 3. And you're right, they do look a little different than the older models. That's because they offer some key advantages that have a huge impact on not only wind farms, but wind techs everywhere. So one of the first things you can see is the magnetic shield plate that we've added. This is a huge improvement and help ensures that the encoder keeps working, even on very old motors that have maybe been magnetized due to flashovers, brake problems, or any variety of other issues. The shielding ultimately provides greater reliability over a longer period of time from the device.
And maybe then you want to show them that shield in the thing, in the camera. And maybe,
here it is.
And then you can flip it over and maybe they can get another look at it. So here's the shield that Ben's talking about.
And so we also did quite a bit of work on the electronic side. So we were able to add more surge and wiring protection into this device. The new units can no longer be destroyed by tower wiring harnesses that may be short from a connector and the ground, or even the power source, or maybe even another connector. Now, this was never a huge problem, but it's great to have that kind of protection nonetheless. One of the most noteworthy features, though, on this device is the diagnostics. And here's why. The LED is not just a power light. There's a boatload of electronic checking and calculations that go into this. Now, I'm not going to dive into all the details right here, but the LED green, when it powers up, means that the unit can see the rotor, the power is connected, and the unit has passed all of the other self-checks. Now, let's say the motor starts to rotate. That means that every single pulse is being checked through the diagnostics to ensure the highest quality. Now, if you get a red light, you know immediately that there's been a problem with the installation. On the other hand, it could be orange, which usually is an indicator of wiring problems. In that case, you can typically leave the power wires connected while you disconnect the other wire outputs, like A and then A naught, moving slowly on down the line to troubleshoot until you've been able to find your wiring problem. Once you do that, you can then ring out the harness and then find the problem.
Can we get us a little live demo?
Yes. So this is the power light that I was referring to. You can see it on there. Obviously, no rotor right there, but
So it immediately checked, didn't find the rotor, and it turned it red. So that's definitely going to stay red, and I don't think you're going to be able to put the rotor in the right place, but maybe you can. Good luck with that, gentlemen.
Right. Right. And these diagnostics, and I do want to talk just from being out in the field and up tower, these diagnostics save tons of time, and not only time, but also money for these different sites. So I think it's something that's really innovative and has been extremely helpful across the board for sites across the country to be able to utilize the LED light for a diagnostics tool. I think that's wonderful technology. Jose, I want to move on to you next. We've talked about the product, the LED light, some of the magnetic shielding. I want to talk a little bit about installation. Everybody wants fast, error-free installation. Is that better, inherently better with these new encoders?
So here we have a blade pitch motor with the rotor is already installed. You know, typically there's, during the long time that these are installed, they become somewhat stuck to the motor. So here is a steering wheel puller. There are 2 tap holes on each side of the rotor. Install the steering wheel puller as such, and you remove the rotor. You know, typically we've seen or heard of people, customers, using pry bars where they just pry the rotor off and move it back and forth. But typically what this is going to do, if you hit any of this magnetic ring, you can destroy it, which is going to send off a bad signal. Another thing we've seen is torches. I will not like this because I don't want to set anybody on fire, but this is a no-go. If you apply any heat to this rotor and it hits this ring here, you know, it's gonna destroy the magnetic signal. You know, the best option that we've seen is this here. If it gets stuck, just use the steering wheel puller, and as you can see, it's pulling up.
This holes in the rotor for, say, you didn't have a floor handy, can you use those as jack screw ports?
Yes, you can just put a screw straight through, tighten them, and it'll push off the face of the motor, and then you'll lift it right up.
That is a great demo. Wonderful, Jose. I appreciate you walking us through that. And so this is the way now where people can actually remove these rotors. What do we replace exactly in the field? I know we've talked about the set screws briefly early on in this podcast. What makes this particular rotor inherently better, and why did you switch over from the set screw?
Yep. So here, you know, this is a set screw. Like what Brian mentioned earlier, you cannot install this backwards because you have to physically face the cam screw and install it onto the shaft. When the old method, you know, you can put it on either way and you can still tighten it to the shaft, which can interfere with the signal. Now, another thing is, as you can see, we have these 2 taps here. On the older set screw, we do not. So it could be a problem trying to remove this from the shaft. So our team has come up with these two where you can either insert bolts and back it off the face of the motor face, or use a steering wheel puller.
That's awesome. And Brian, I wanted to touch on something else with you. It seems like this obviously is a massive time saver, right? Being able to pull off these rotors from the motor shaft, and especially when you're considering you don't want to do damage to the rotors. Do you have any other additional installation advice, Brian?
Yeah, one of the real keys is to use the gauges. Jose, can you show the gauges on camera? Thanks so much. So the gauges, basically, there are two styles of gauges. There's an older metal gauge, and then there's a modern one that is made of FR4 circuit board material. And it's really important that you use the gauges or the housing to check the position.
That's very interesting. Talk a little bit more about these gauges. I'm looking at it now, and before we hopped on this podcast, we talked about it being almost like an oversized dog tag. Could you talk a little bit more about these gauges and why they're so important for the installation?
Yeah, so both of these gauges work the same. So there's a little picture on the side of the gauge, and Jose, would you hold that up the camera so that they can see the picture? And what that does is that shows you how to use it. One of these gauges comes in every box that we ship out with every encoder, and the flat surface sits on the motor. There's a little notch that goes over the motor C-face, and then the bigger overhang part of the gauge should touch the outer surface of the rotor. Jose's setting things up to do this live. So basically what he's doing, as you can see, he's using there's really a two-handed trick that's going on here, because he's using the gauge, he's holding the rotor, and he's going to hold that gauge steady, then he can tighten with the cam screw. There's definitely a trick here, because if you don't support with the second hand, what you're going to do is push that rotor down vertically, and now the rotor's probably going to be too close to the motor. That's not the optimal place. Will the encoder work in this position? Well, maybe. Our encoders are pretty tolerant. But as the motor moves, there may be more shaft movement. The encoder may have trouble seeing the rotor since it started in the wrong position. You're going to end up with a red LED and maybe drive trips if your encoder rotors aren't in the right places. Even if you aren't replacing rotors, definitely gauge them every time you take a motor brake assembly apart. Because I've climbed towers, we've seen all kinds of examples where rotors are incorrectly mounted even for years. The system works, but when you take them apart, you can improve the rotor position to ensure they're going on performing for even longer.
That's great, Brian. And Jose, I appreciate the tip on how to hold the rotor and gauge at the same time. Is there any other way to check the rotor position? We've all been up tower, and there aren't any gauges to be seen anywhere, and sometimes we ultimately lose them.
Yes, as I'm here, I'm going to put this on camera now. So one way is here, you can see these little pads in here. So if you align, I'm not sure if you can see it. Can you see what I'm pointing at here?
Yes, that comes in nicely.
So these notches here, if you line the rotor up with it, those are indicators that you have positioned the rotor in the right place for the sensor.
So to show them an example, we'll go ahead and put that straight on the motor, even with or without the rotor, that's okay, and just show how they would actually check that.
And here, there's a little notch here. So once you install this, this edge of the rotor will line up with this edge of the stator housing.
That's very, very interesting. Could you walk us through and maybe give a quick demo how you would actually do that up tower?
Yeah.
So first he's going to put the rotor on. He's going to use the gauge to get it in the right position, just for the purposes of getting it set.
This is actually the wrong one.
And Jose, as you're installing this, maybe just for the viewers who are tuning in, maybe talk us through what you're doing as you're installing this encoder.
Okay, so here I'm installing the rotor onto the motor shaft. There's a keyway, so you just align it up. It may take a little bit of a wiggle just to get in position, but then it should be fairly easy.
And I want to emphasize that he didn't have to force that. You're not forcing these on the shafts. It's a very comfortable slip fit. Now he's going to use the gauge, and you see he's judging that height. So he's showing the gauge at the proper height. Now he's going to use the same hand to hold the gauge and the rotor at the same time. That's basically what you do, is you're going to hold it all with one hand, so you can use the other hand to tighten the things. There you go. So that's how he's doing it. Some people use 2 fingers or whatever, but the whole goal is he's trying to figure out, is that rotor in the right place, and not shove it down too hard against the motor. Now he's going to tighten the rotor, and he's just tightening it for purposes of demo. In the real world, he would have tightened it a second time with the long end of the wrench.
Mm-hmm.
Now he's going to use the stator, and now he can actually check the height. One thing he's doing is, you guys might have noticed, he's lined up the outline of the stator with the paint outline that was already there. Because if he stacks this stator on top of paint, hey, that's going to be several thousandths of an inch too high. So now he's going to actually show you that that is even. You can use a little metal rule. He's using a little piece there. Anything will work just to reach in that hole, just to demonstrate that it's a flat area.
Mm-hmm.
So he's demonstrated using the stator in place of a gauge.
So you guys could basically use the product itself to check the rotor position, correct?
Correct.
That is fascinating. I appreciate that demo too, Jose.
And this is how you would view it on the opposite side of the motor face. These little notches here align, as long as the rotor is flush with that, you're fine. The rotor will be in the correct place.
And how would you be able to identify with the stator that maybe the rotor wasn't installed correctly?
With let me see that better. So I'm going to just plug it in. Let me know, can you see this LED?
Yep.
Okay. Now I'm just going to orient it a different way. There's no rotor present. You know, this is typical. You get the same LED red light if the rotor is misaligned. So I had it wrong. I know, go ahead.
One thing you'll notice there is once you've got a red light, it's going to stay red until you cycle power. It won't let you twiddle and fiddle. So you're going to have to make sure it's installed right, and then he's going to get a green light. So you see, when he did it wrong the first time, he had to cycle power for that red light, that alarm condition to reset.
Now, if I remove this rotor, it's not in the right place, you'll get a red light. It's not reading the signal of the rotor, the pulses. So it's not present. Now, I cannot just place the rotor back into place and then expect to get a green light, as Brian said. We'll have to cycle power in order to reset.
Right. Yeah, that's a wonderful demo, and something for the technicians out there listening to this podcast to keep in mind is you have to cycle power before you get that green light once you appropriately install that rotor into the stator. I actually want to still talk about the rotor and especially the magnets, Jose. We'll keep it here with you for now. I hear there are competitors that have superior magnets, and we don't necessarily like to talk about competitors in the space, but there's a lot of talk right now and buzz around a stronger magnetic technology. Can you just do a quick quick dive into the magnetic technology of the Avtron encoder?
Yeah, so the key is the accuracy of magnetizing the ring on the rotor itself. It's not so much as to say that a magnet is more powerful or otherwise. But one thing is that if to say that this is more powerful of a magnet, it's also going to attract ferrite material, which in return could, get into the gap of the rotor and the sensor and scrape either the rotor or the sensor or both, and cause either fault codes or premature failure.
Right. And so just as
exactly.
Just as a next step for this question then, so basically what you're saying is it's not the strength of the magnetic shielding or the magnet itself, it's more so the accuracy. So do you mind just talking a little bit about the accuracy of the magnet? How were you guys able to develop a product that's so accurate when it comes to the magnetic technology?
Yes, so we have developed a really well magnetized machine, which allows us to put the pulses very accurate around the rotor itself, which allows for a good signal to be produced. You know, if I were to do this, let's say per se by hand, you know, obviously it's not going to be magnetized very well. We have a machine that's spacing these pulses to within a tolerance, which allows for a great signal.
Right, thank you. Yeah, it's good feedback and something that I really want to hammer into the audience out there, because a lot of the buzz, as I've said, is about the stronger magnets, but really, to reiterate, it's about the accuracy of the magnet. I think you guys really have that technology dialed in. While you have the rotor out, let's talk about some of the things we're seeing in the field, such as the refurbished or even reused rotors. A lot of different sites will say, hey, you know, somebody came on site, they say they have a similar magnet to ours, we can keep the same stator, or even they're taking old stators out of the field and rotors and replacing them with their own rotor. What are you guys' stance on being able to refurbish these encoders? Do you think it's actually a value add, even if there's an upfront, let's say, cost savings for those, for customers to actually put those in their towers?
So, no, even though there may be some additional or some incentive or initial cost saving, and during the long run, it's not actually going to cost save anything. It's, you know, you have to pay for technicians to climb up the tower. You know, there's in many circumstances, people do not want to climb up unless it's an absolute emergency. You know, if you reuse a rotor, I've seen rotors have gouges from ferrite material getting caught inside of there, or during poor installation to where they're using a pry bar and so forth.
Can you guys hear me okay?
Yes.
Now we can.
Oh my gosh, my computer muted me when the camera switched, I think.
That's okay. Do you want to do your intro piece again?
Yeah, absolutely. And we'll edit this part out. So I was just saying, you know, Jose, I appreciate you showing us and just walking us through the refurbishment process and why it's maybe not a good idea to refurb a lot of these encoders. You talked about having to climb, and that's definitely a huge portion of it. The other portion is unscheduled downtime, which is lost revenue and profitability for a lot of these sites. If you talk to any technician, especially in the territories that you cover, Jose, the Midwest is where I live and also frequently service, nobody wants to have to climb out of the nacelle, down into the hub hatch, and then service a failed refurbished encoder. What they would really prefer is having the assurance and knowing that the new product that they're installing into their pitch motor is going to perform, it'll be reliable, and they won't have to do those unscheduled climbs, you know, in the middle of a freezing Minnesota winter, for instance. So I think that was a wonderful overview, and I think really sites and technicians will understand the value add of just replacing with new with this accurate magnetic technology, installing it appropriately, as you guys have walked us through. So I really appreciate that overview. Ben, speaking of new encoders, I wanted to ask you, you know, Avtron is a household name per se in wind. How many encoders do you actually have out in the field today?
Now, we've got over 100,000 of these encoders working in wind turbines all around the world. That's because of their great record for reliability.
And you guys are also OEM approved, correct?
Yep. These are, here's the AV56 Gen 3.
Right.
And can you repeat that? I didn't quite hear you.
Sure. And you guys are also OEM approved, right, for the GE platform?
Absolutely.
Awesome. And then You know, we're talking a lot about, and you hear this even in the news today, President Trump had an executive order talking about parts for power generation need to be based in the USA. We don't want to source from particular countries. Where are these encoders made?
All of these encoders are made in the United States of America. So luckily for us, we're considered an essential industry. And that's mainly because of all the government, utilities, and other critical infrastructures we supply. We are continuing to run throughout the COVID crisis.
I love it. And I think it's something that's, it really is critical infrastructure, power generation. And the encoder technology, while it's a small component, plays such an integral role in those turbines performing and remaining online. Ben, I appreciate the rundown. Steve's off camera. I think maybe Steve did finally pop onto camera here. We didn't get a formal introduction to Steve, so I've got a question for you. But first, Steve, since you're on camera now, could you give us your quick background and intro for the people who haven't met you yet?
Absolutely. I'll reiterate first Brian's thank you and our appreciation for having the chance to be here with you guys. We know wind is an area of growth. There's a lot of industries that are flat or keeping pace with GDP, but wind is not one of those, and alternative energy in general. And because it marries so nicely with our core, you know, what does the Avtron brand mean? Durability and uptime more than anything else. We know that those are important. So it's a good fit. Kurz is a great, excellent partner for many years. My personal background is in marketing and product development, primarily of industrial goods, some household power tool names. I've developed tools with Ingersoll Rand and DeWalt power tools. I've been with the company here for 2.5 years, working alongside Brian, and as we've grown, really asking the questions of where can we go next, leveraging our strengths, and I think we'll be able to share some of that today with you guys.
Sure. And I appreciate your quick rundown. And we're equally as excited about the partnership between Kurz and Nidec Industrial Solutions. Steve, you're talking about different applications and the growth of wind. You're obviously the director of product development and marketing, so I'm sure you've always got some new projects in the pipeline or in your back pocket. Do you guys have any other wind products for the obviously wind application that you'd like to share?
Absolutely. And at the time, it couldn't be better. We're actually in the process of launching a new encoder primarily focused on wind for the application of backup generator. We call this the HS44. It may look like a similar form factor and fit as other backup generator encoders. I'm just going to put this down here. HS44 was developed with 3 principal drivers in mind. One being drop-in replacement. We don't want to have anybody learn how to install an encoder when they're up tower. It's a drop-in replacement, both mechanically and electrically. Durability. The Avtron brand namesake is all about durability, so we have a magnetic solution to optical encoders. We're going to talk a little bit more about that in a few minutes. And the other is value. So value painted with many different colors. One is uptime. It's reducing unnecessary climbs, but also cost of acquisition and maintenance. We believe that with a magnetic solution and no compromise on signal quality, you have a much better overall package from an American vendor made in the U.S.
And we love that, made in the US of A. That's awesome. And we talked about the AV56 Generation 3 diagnostics with the LED light. Could you guys walk me through the diagnostics capabilities of this HS44 Gen encoder?
Yes, absolutely. So I've done a little bit of pre-disassembly. The functionality benefits in terms of what we call Gen 3, that was a lot of that green, red, or orange signaling through the LED. It's the over circuit and faulty wiring protection. So ground faults and shorts and miswiring don't kill the encoder. That's important. It does not kill the encoder. I don't have the plug in a battery and show you the LED, but here is the LED. If this were a dual output, there'd be 2 of them. So I've removed the cover screws. There's the light pipe for the LED, and I don't know how much close-up resolution you can get, but what can you tell of our electronics? Does it look all complicated and green circuit board? Sorry. And lots of components sticking out in the air to get damaged?
Absolutely not. It looks super simple.
Super simple, and what you probably can't appreciate from there is that it's fully encapsulated in a protective coating, about 3/8 of an inch thick. So impervious to humidity, impervious to dust, oil, and other fluids that can get in and damage.
That's phenomenal. So basically, these are fully potted electronics. Is that correct?
That's correct. Fully potted electronics for all the reasons that I just mentioned. And again, I always, as a product guy, go back to the application. And I think and you can think too, where are these going to be installed? Many times it's hot, dry, arid areas where there's huge fluctuations and swings of temperature on a daily basis, cold at night, hot during the day. That creates condensation, which can corrode electronics, and it can cloud optical discs. Unnamed competitor, L or H, has an optical disc and unprotected electronics.
See, if you can just see the electronics laying there on the circuit board. I mean, if a drop of water gets on there,
that'll corrode. Likewise, an optical disc, especially glass ones, are prone to chipping if there's high vibration, or scratching if you get dust in there, or clouding if you get moisture in there.
Right. It's almost like somebody
didn't
ever.
Familiar to your listeners, but it should.
Absolutely. It's like whoever wrote the manual had never climbed a wind tower, basically. For some of the other people's encoders, that's the redacted name. That's wonderful, Steve. And I also want to talk about mounting. How does the new HS44 mount in comparison to the older models of these encoders?
So, the first driver of the three that I mentioned at the outset of this development was drop-in replacement. So this is center bolt mount. We have 3 shaft options depending on the manufacturer of the OEM of the generator. You can have a 12 millimeter straight, 16 millimeter straight, or a 17 millimeter conical with a 10-to-1 taper. It's a single bolt, M6 or M5. We ship all the hardware. We don't make anybody's stock. Ones with M6s and ones with M5s. And as well, it's threaded for M8 for jack screw removal.
just like the cam screw rotors.
Just like the cam screw rotors, if you ever needed to.
And it seems so simple. You talked about the electronics, the mounting. I think that when you build a product with the technicians in mind, it really does add disproportionate value to the field. And I love that you guys have thought about what are the conditions these guys are having to work in, guys and gals having to work in, and how can we ultimately make it easier on them to install our product. It really seems like this is going to be a huge hit, especially with installers. Jose, could you touch up on that a little bit, just about some of the progress you guys have made?
Yes. We think that this next installation is going to be our next big success. But ultimately, it's the installers all over the world that's going to give us that input and let us know if how they feel about the new and big improvement.
I love it. And let's say, so we can link to different links in our show notes here for anybody listening on different podcast platforms. How can people get more information on this brand new HS44 encoder, Jose?
Yes, we have good manual and data sheets and other information on our website. That's www.avtronencoders.com. Or also Kurz also have links on their website. So, you guys, it's a great place to start.
Absolutely. And we'll definitely build out a nice little page here for people to have a central resource to get in touch with you and understand the value add of this new HS44 product. And then also, if they want to try out the AV56 Gen 3 model as well, we'll be able to have that information underneath the show notes and then obviously on our website. Brian, this is the last question of the podcast, unfortunately, but I definitely want you to field this one. Do you guys have any customer success stories with the HS44 thus far, this new product?
Yeah, we're very excited about this new product, obviously, and we've taken it to some of the world's largest manufacturers. And one of the largest manufacturers of wind turbines in the world has really embraced it. As Steve talked about, the design and durability, when you look in there, the design is dead simple. Then they also did the compatibility testing that Steve talked about so that it did pass their mechanical and electronic 100% compatibility testing. The other thing they're doing is talking up the diagnostics, like Steve was talking about with the LED. So they're talking it up with their customers as an added value. Now you know whether the encoder is working on the back of the generator. And that works a lot better than just swapping parts until something works. If you've got an encoder problem, are you swapping cables? Are you swapping wires? Are you swapping drive boards? That's a very painful process. Now we're taking this product with our key partners, Kurz, to the end user aftermarket. And we really think this is going to help wind techs and repair shops, not just OEMs working on generators.
I would agree 100%. From our perspective, being able to chat with different owner operators across the country, especially those in the aftermarket outside of their warranty periods, I know this is something that will be a massive hit. I'm very confident with that because you talked about the time saving, the cost saving when you factor in unscheduled climbs, having to swap out different parts and diagnose what is the true issue here. I think the way that you guys approach the market with the technicians and turbine operators in mind is phenomenal, and we're really excited about the future growth and partnership with you guys. That is the last question. Unfortunately, we've also run out of time, but I want to thank each and every one of you, Steve, Brian, Jose, Ben. Thank you so much for being on the show today.
Thank you again.
Thank you very much.
Have a good one.
Absolutely, gentlemen. This is episode 11 of the Kurz Wind Podcast with Nidec Industrial Solutions, and we're checking out.